Um, Today's lecture, I'm going to introduce some of the concepts which are slightly difficult to grasp, but don't worry about it. This is part of my series of lecture in which we discuss different processes, different type of equipment, and different type of methods that are used in the oil field industry. Today, what we are going to talk about is cementing. It's one of the most critical operations that is done once the well is drilled or while the well is being drilled. So it's very, very good. It's very important to understand how how critical this process is and what can actually go wrong if this is not done correctly. So um, what we are going to be discussing and what you will be able to comprehend at the end of the session is that you will be able to understand what are the different uh, well construction processes that are used to drill a well and to complete a well, type of drilling rigs, rig equipment, primary rig equipment, what are the objectives of a cementing job. Um, there are two different things. Cement is one thing, cementing is one and another thing. We are going to talk about both of these things because cement is primarily the product and cementing is the process. And finally, we are going to talk about different type of cementing equipment, cementing additives, different types of cementing, and then we are going to conclude the presentation with a question and answer session. So life of the well is very critical. Critical in a way that it's not based on few days or few months or few years. It's very comprehensive. It usually spans over multiple decades. So you might have heard about wells that were drilled in 50s and 60s and 70s, and they are still producing right now. So it's not just for a short term period. You have to, when you are planning the life of the well, you have to consider all the different phases of the well, um, and different type of declines and pressures and temperature it will go through over the period of time. Um, Exploration is where it all starts, which is primarily to locate the hydrocarbons with the seismic operation and see if it is even feasible to continue through the reservoir production. In this phase, we work very closely with the geologists, geophysicists, and petrophysicists, and we try to determine how much oil is there. And the process of determining how much oil is there is called reservoir appraisal and development process. And then once that is done and it is determined that it is very feasible to produce oil and gas or hydrocarbons through the well, we proceed to what we call a drilling operation. And the drilling operations, we use different type of, we not only drill, but we also use different type of subsurface methods like wireline and drilling and measurement services, in which we try to determine how much oil is there in theory as well as in practical, and what are the recovery estimates. In this one, we work very closely with the geologists, petrophysicists, and reservoir engineers, and we try to develop the reservoir with the drilling services. And last but not the least, once the drilling is completed, logging is completed, we do perforation and the well starts producing. When the well starts producing, it moves to the next phase, which is called testing, in which we try to determine how much oil, how much gas, how much water, and how much other hydrocarbons are present in the reservoir. And once that is done, it goes through the full-fledged commercial production. And at the very end, once the well has stopped producing, we do what we call plug and abandonment, in which we actually effectively plug the well with the cement and we try to uh, remediate the surface so that it goes back to its original shape. So in during all these different life cycle phases of the well, cementing plays a very crucial role. Cementing plays a very important role when we are completing the well, right over here, when we are perforating the well, right over here, and when we are abandoning or decommissioning the well, right over here. Um, Different type of cementing processes, but cement, the basic product will still remain the same. So why do we cement wells? This is a section of a virgin geological formation. One of the geological formation in this virgin a cross section of the formation actually contains the hydrocarbon or the money. And the objective is to drill a well to make a path for the hydrocarbon to flow. The objective of the cement is to focus the flow path of the hydrocarbons so that it actually flows through a tubing. And tubing is nothing except, imagine it's like a straw. And the objective of cement is to focus all the hydrocarbons so that it flows through that straw. So that is one thing, but it also plays a very important second role, which is called zonal isolation. And that is to provide some sort of isolation, some sort of sealing between the different type of zones that you see over here. You can see this is the hydrocarbon zone, but then there are different type of other formations that are present. And you can see there is a water or a surface aquifer that is present over here. So the objective of cement is to provide a zonal isolation between the environmentally sensitive zones and the producing hydrocarbon zone. So it provides a seal between the producing zone and the environmentally sensitive zones. Moving on, we said that we are going to talk about different type of drilling rigs. This is very important because a type of a drilling rig can actually play a very crucial role on what type of cementing job you will do. Uh, Basically, there are two types of rigs, the land rigs and the offshore rigs. In the offshore rigs, we have two basic types. One is called floating platform, and the other one is called fixed platform. In the floating platform, there are no legs that go all the way to the bottom of the sea. It actually has ballast tanks in which the level of the water can be changed and it can be balanced. And then there are fixed platforms in which tension legs like these go all the way to the seabed and they are anchored to the seabed. So some sort of a drilling equipment, what you see out on the picture is what we call a floating offshore oil rig. In this floating offshore oil rig, we have different type of main components. Um, we have what we call over here a blowout preventer stack, which is something like this. It has rams, it has pipe rams and blind rams, which can be used. It is actually an emergency device, which can be used if there is an uncontrolled hydrocarbon incursion into your surface, into your casing or into your production. So they can be closed and it will curtail or it will stop all the production and it will prevent any accident from happening. They can be either located on the seabed or on the rig floor as well. Some of the subsea blowout preventers are specially designed so they can be operated under the water at a very great depth. As I mentioned earlier, that these are very important safety device that prevents the well from blowing oil. Going back, if we go to the derrick of the oil rig, there are different components. The main structure, it is the main structure through which the drilling operations is performed. And one of the aim of the derrick is it can lift or it can lower all the casing and the tubing and all the other equipment that goes into the oil well. So it has to have a lot of lifting capacity. Uh, it should be able to suspend millions of pounds in weight, and it can be also used to apply weight to the drilling string. And as you know earlier, you need to apply weight to the drilling string so you can actually penetrate and drill the hole better. Uh, One of the things about the drilling rigs is that they will have a derrick in one form or another. It's like a characteristic of a drilling rig. Then we have something which is called casing. And this is very important to understand what casing actually do. Because if you can understand this concept, you will be able to understand the concept of cementing as well. And casing is essentially a string that is necessary. In every well that you will see, one thing will be universal. It will have a casing. And the importance of casing is that it helps to produce the fluid or hydrocarbon successfully. The casing is essentially a large pipe that is run into a wellbore to protect the integrity of the hole and to isolate different types and different parts of the formation from each other and through the surface. So you will drill a hole and then you will have this metal casing that you will lower, and different depths will have different casing. So it will be all telescopic that you will see in the further slides. It will start a bigger casing with the smaller casing and the smaller, and all of this is suspended through what we call a casing hanger. Now, the last system that we will discuss in the drilling rig is what we call a mud system. Now, what mud has, as the name suggests, it, it is essentially a mud with a lot of additives, but it plays a very crucial role in what we call drilling of the well. Um, this mud with the additives is actually pumped downhole through what we call a mud system. Now, mud system has mud pits, and then we have different type of mud pumps. These pumps are pumping at a very high pressure through a discharge line into series of different pipes through a drilling string. Um, Mud does multiple things. It helps to keep cool down the bit, because if the bit is running dry, it will become very hot and it will increase the wear and tear of the bit. Other thing it does is it helps in improving the rate of penetration of the drill bit, so you can actually drill faster with a mud system. The other thing which it actually does, and very important thing that mud does, is that it applies pressure to the formation so that there is no uncontrolled incursion of hydrocarbons into the drilling string. And you want that because you don't want a blowout. You don't want an uncontrolled incursion of the oil and gas, because then it becomes very difficult to contain. So mud will apply that pressure, that weight, to keep everything within the borehole. Now, as I mentioned earlier, that you have casing. Casing is essentially a big pipe, metal pipe, that is lowered into the hole, and it provides the zonal isolation. It prevents the different formations from mixing into each other, or a high pressure formation pumping into the low pressure formation. And all of this casing, which you can see right over here, it starts with the biggest one, which is called conductor casing. We are going to discuss different types of casings in next few slides. It starts with the biggest one, which is called a conductor casing. Then you go to a surface casing, then to intermediate casing, and then to production casing. And one thing which you can see is all of it is telescopic. It all tapers down. So it starts with the biggest one, and then it goes to the smallest one. Now, we talked about casing, we talked about different type of oil rigs, we also talked about different type of main systems that are on the oil rig. But the question is, what is a oil field cement? What cementing actually means? But before we get into what the cementing process actually looks like, let's talk about what the oil field cement is. So oil field cement, if you have heard about cement before, it's used in the construction. It is very much similar to a construction cement, but it is a special type of cement, because it is made of certain additives that makes it special compared to a construction cement. So it is essentially made of Portland cement clinkers with some additives like calcium silica hydrate as a main component, and then adding a proper amount of gypsum and grinding aid, which the petroleum industry uses for drilling oil and gas wells. It has to conform to a certain API. API is American Petroleum Institute specification, which is called 10A. It has to conform to that. So the composition of the cement, its properties, specifications are all governed by the API 10A. And it needs to perform consistently in well cementing applications at extreme depths, temperatures, and pressures. Because when you start drilling, and as you know that extraction of oil and gas is becoming difficult and difficult, because we are going deeper, we are going into more high pressure formations, high temperatures. So the composition of cement is constantly evolving, because it has to cater for all those extremities. So oilfield cement has to have all these specifications to withstand the depths, the pressures, the temperatures, and has to be slow sledding and able to withstand the extremities. But we have different type of additives in cement to make it suitable for the oil and gas industry. It has accelerators and retarders, so it can change the thickening time of the cement, and then It can alter the compressive strength or the tensile strength of the cement. We have extenders which can reduce the densities or change the slurry yield strength. Then we have weighing agents which can change the density, actually increases the density of the slurry. So your slurry becomes more and more thick and viscous. Then we have different type of dispersants, H2S prevention or H2S mitigation additives. We have different type of fluids loss control or loss circulation material, different type of things, different type of chemicals that are added to that cement, which makes it very different. And the cement can be used from a temperature ranging from below freezing in permafrost zones to almost 350 degrees Celsius, which is in thermal recovery and geothermal wells. The pressures encountered can range from almost like 3,000 psi's to 15 to 30,000 psi's in very deep wells. In addition to severe temperatures and pressures, well cement must be required to deal with weak and porous formations, corrosive fluid, H2S, CO2, and overpressured formation fluids. Um, these cementing additives that are added to the cement will modify the behavior of the cement, which will allow for the successful slurry placement under the most extreme conditions. So cement that is used in the oil field is just not a normal cement. It has all these different additives that makes it special. Now, we talked about construction of the well and different type of casings. This is just a more structured schematic of what we talked about. You have your conductor casing at the top, followed by surface casing, followed by intermediate casing, and then your production casing. And all of it, if you see, is hung from what we call a wellhead. The wellhead has a casing hanger on which you can actually hang all these casings. So essentially, an oil well is composed of series of tubulars of decreasing size arranged telescopically. The most critical word over here is telescopically. That means bigger at the top, smaller at the bottom. And each casing size is designated with a specific name. You have conductor, surface, intermediate, and have different dimensions. Now let's dive a little bit more deeper into the casing, because casing is essentially the thing that cementing is used for. So going deeper into the specifications, conductor casing or conductor pipe, you will hear both of these words in the oil field industry, is the most biggest of the casing, which can range from 16 inches all the way to 30 plus inches. And the setting depth can be all the way to 40 feet, 1500 feet. And it has a very specific function. It protects the rig formation, it prevents the formation fluid loss and loss circulation, and it prevents rig from sinking into the hole when you are drilling it. Then we have what we call a surface casing, which can be all the way from 7 inches to 16 inches. And surface casing has one critical function. It supports the blowout preventer and the wellhead, because wellhead is a very, very heavy component or the very heavy piece of equipment. So surface casing is there to support the wellhead, preventing it from sinking in. And it also prevents the contamination of the freshwater zones, because as you know, freshwater zones are very shallow zones. So you want to prevent these aquifers so that they don't get contaminated by the hydrocarbons. Surface casing is there to make sure it happens. And then we have intermediate casing, which is smaller than the surface casing. So you can see over here, it can go all the way from 7 inches to 11.75 inches. And it is to protect the production fluid from corrosion. It protects the hole from high formation pressures, because when you are drilling and as you are going deeper, the pressure from the formation can change. And then it prevents the loss circulation. And loss circulation means that when you are pumping the drilling mud for drilling, it prevents the mud from going into low pressure reservoirs or permeous reservoirs, because you want that mud to go down to the borehole and come up to the rig floor, so that it can be circulated through the mud system. You don't want it to go into the formation, because once it starts happening, you will start losing mud, and mud is usually very expensive to replace. And then we have production casing, And production casing is essentially protect downhole producing equipment. You can have electrical submersible pumps, you can have PCPs, you can have gas lift equipment, you can have different type of subsurface safety valves, um, and the production casing is there to protect it. And last but not the least is liner. Liner is not universally used, but in some of the cases, a liner can be used. But in most of the oil wells, you will see that production casing is the last type of casing. And this is just all of that casing cemented into the place. Now, cementing has two more important component functions. Number one, it provides zonal isolation. You can see over here we have different type of formations. We can have shale, we can have hydrocarbon zones, we can have aquifers, we can have limestone, sandstone, different type of permeous and impermeous formations. It provides the zonal isolation. It provides the sealing. It makes sure that the fluid from one formation will not go into the other formation. But then it has other functions as well. The cementing will make sure that the string, the casing string, which is all metal, is protected from corrosion. It maintains the well security during the placement. It supports the axial load of the casing. It does not have the capability to have or to have a lot of tensile load, but axial load, it helps in that and supports that. And then um, it is there to meet the government regulations, because the government regulations in each and every country would want you to cement your casing. Now, let's talk about primary cementing, or the main type of cementing that we use in the oil field. And the primary cementing is placement of the cement slurry into the annulus between the casing and the formation. Annulus is the space between the casing and the formation. Formation is your raw formation, drilled hole, and then casing is your metal casing, and primary cementing is to make sure that you place your cement slurry into that annulus. Because if you don't do that, what will happen is that the plastic formation will deform, it will creep, and it will collapse or shear your casing. And you don't want that. You want your casing to be intact throughout the life cycle of the well. And then also you have corrosive waters with H2S and CO2. And primary cementing is there to ensure that the corrosive fluids do not come in contact with the steel, because if it does, it can corrode the steel to a point where the integrity of the steel is gone. And primary cementing is done to protect the borehole from collapsing, because as you know, the earth is shifting. You have tectonic activity, you have seismic activities. So the earth is always shifting. You want cementing to protect the borehole from collapsing, because if you don't do it, your casing will shear, and then in that case, you don't have control on your well at all. As I mentioned earlier, zonal isolation is very important. This is your casing right over here, the black pipe that you see. And if you follow this contour, this is your formation. And the cement is this gray part right over here. So it goes into the annulus between the casing and the formation. And as I mentioned earlier, zonal isolation is very important. And you can see right over here in this animation that if you don't have good cement, that means your cement is not completely sealing the space between your formation and the casing. What will happen is this salt water will travel along the casing and contaminate the freshwater bearing formation right over here. So it went from this salt water and oil went from here to here and contaminated this freshwater formation. And we have so many examples of a cementing job going wrong or cementing job not done properly, which resulted in a lot of issue. An example of this is OKN32. This is taught as one of the textbook examples of how cementing had gone bad and resulted in a big disaster. OKN32 well was in Algeria, which was drilled back in 70s, and it didn't had a very good cementing job, almost too poor and non-existing cementing job, which allowed fresh water to travel uh, um, between between the salt layers and the fresh water. The well was lost, and the huge salt lake was formed, which can be still found in the desert today. This happened back in 1979, and these were bad cementing job and complications that arose from placement of a 2,800-meter deep oil production well in Algeria. Um, so, which you can see right over here. The salt water actually went into the, sorry, right over here. So this is a picture of that well. You can see the lake that has been formed, a couple of pictures from the same location. And then that, last but not the least, that is just one example. We can have bad zonal isolation can result in a huge blowout, which you can see right over here in the desert. We have lost, we are well with a big crater formed and fire because of the uncontrolled exposure of the hydrocarbon and loss of well control. Now let's talk about the basic cementing process. We talked about cement, what it is made of. We talked about cementing, how it is used in how it is pumped between the annulus, which is the space between the casing and the formation, and how it anchors or it provides that sealing and zonal isolation. But let's talk about how it is done. This is just a quick animation that I will play. I will pause in between to talk about certain things. Um, but certainly the first and foremost is what we call a mud circulation by rig pump. So the high pressure pumps on the rig will circulate the mud through your casing and into the annulus. And then you have your mud return line, which through the mud return line, it will go into the mud pumps and the reservoir, and then it will be recirculated. So all of your well, including your casing and your annulus, is all filled with mud. After that, we will do a quick pressure test to make sure that usually this pressure test is done like 3,000, 5,000 PSI to make sure that everything is sealing, there is no leakages, there is no lost circulation. And once that is done, then what move to next phase, which is called pumping, wash, and spacer. What happens in there is that there will be water and chemical that will be pumped into the well, which you can see right over here. This is at the top, on the right over the mud, you have water and the spacer. Then we will open this gate right over here, and we will drop what we call a bottom plug. So this is the bottom plug. It will be dropped through the casing. And then what we do something which is called pumping the lead slurry. So lead slurry has a different density compared to the tail slurry. It is called lead slurry because it is pumped at first, followed by tail slurry. So you will see in the animation, we will be pumping tail slurry. So this is the lead slurry, and this is the tail slurry. Different densities, different additives, just different specifications. This is your bottom plug. It is all the way at the bottom. And then we will open certain set of valves and the gate over here to drop what we call a top plug. This is the top plug, very much similar to the bottom plug, but you will have top plug pushing all that cement. So the cement that was in the casing is now displaced, and it is now filling the annulus, which is a space between your casing and the formation. And then you have your mud again pumped through it. Again, we will do a quick pressure test. We'll make sure everything is sealing. We'll make sure that cement is set. And once that is done, your cementing job is completed. Certain things which you saw in that video, we saw bottom plug, we saw top plug. This is how they look like. There are some certain other components as well, like centralizers, float collars, and float shoe. We are not going to talk about these because it just will expand the scope of this presentation. But Let's talk about some of the key processes. One of them is mixing cement, and the other one is pumping cement. In the mixing cement, you have these big bulk plants, these big mixers and pumpers on the surface. These could be either skidded or mounted on a truck. We are going to see the couple of pictures of those as well. But essentially, what they do is that the surge tank, which you can see right over here, let me change my pointer options. The surge tank, which you see right over here, holds the dry cement. The displacement tank on the skid holds the water. So this is your displacement tank. And you can see two loops over here. One of them is what we call a water loop. The second one is called uh, a slurry loop. And the third one is what we call a dry cement loop. To mix the slurry, the centrifugal, so what will happen is that the surge tank will hold the dry cement and the displacement tanks will hold the water. The water and the cement are combined in what we call a mixing bowl right over here, um, and then piped into the mixing tank. So from the mixing bowl, once it is mixed, the water and the cement, it will move to the mixing tank. In the mixing tank, it will move further. Then a centrifugal pump, which is located right over here, will circulate the slurry from the mixing tank to the mixing pool right over here, um, and back into the mixing tanks. As the slurry will recirculate, more and more water is added along with the dry cement until the slurry will achieve the desired density. This is very important. Until it reaches the desired density, you will keep on running this loop. These are just a couple of pictures of skidded units. You can see right over here, you have your big uh, batch tanks right over here, and then you have your your trailer mounted with a semi. And this includes like all your pumps, all your mixing tanks, etc. It comes in a skidded for a way like this, and as well as the truck mounted. The second process when we are pumping the cement is essentially the pumping of the cement. And in the pumping of the cement, the loop will change a little bit. When we are pumping the slurry downhole, once the slurry has reached the desired density, then it is sent to high pressure triplex pump. So mixing tank through a centrifugal pump will push it to a high pressure triplex pump. It's called triplex pump because the head will contain three inlets and three outlets. And this will pump the slurry to the downhole through a cement head. Uh, all of it is done once the slurry has reached its desired density. But once it is pumped, it goes through what we call a cement head. Now, cement head is a very interesting piece of equipment. The reason for that is that every cementing job will have a cement head. Head has multiple valves and multiple gates. So essentially, cement head has a couple of functions. It will release your bottom plug. It will release your top plug. It will help you to pump the slurry downhole. Uh, and it will make sure that your well controlled is maintained. So what you saw earlier was what we call primary cementing. But then there are other types of cementing as well. One of them is called plug cementing. Plug cementing is essentially you will have a very small amount of slurry that is placed in the borehole. So you will have small amount of slurry placed over here, essentially plugging it. Then you will put another small amount of slurry over here and then over here. And this is done for multiple reasons. It can be used for site tracking abandonment. So one of the critical reasons why plug cementing is done is once the well has stopped producing, you will install these or you will deploy these cement plugs. So essentially cap the well so that the formation fluid cannot come back into the tubing. It is done for a couple of other reasons as well. For example, when we have a depleted zone, it is done to plug that zone. It is also done for abandonment, site tracking, as well as loss circulation to prevent loss circulation. The other type of, this is just an example of the cement plug. What will happen is that you will plug, you will have a small amount of slurry placed in the borehole, and you will just provide that sealing, that zonal isolation, so that there is no more incursion of oil and gas into your tubing. And then we have something which is called remedial cementing as well. This is a cementing that is done after your primary cementing is done. Remedial cementing is more like an intervention job. It is done if you find that the primary cementing was not done properly, or if there are other issues with the borehole. For example, it can be used to plug perforations. So perforations are essentially these holes that are shot through perforating guns into your production casing. So in the production casing, you will have all these holes that are helping oil and gas to just flow naturally, unassisted into the borehole. Sometimes these needs to be plugged. So what you will do is you will pump cement to plug these holes. Sometimes it is used to repair corroded casing. So if your casing is damaged because of the H2S, CO2, or other corrosive liquids downhole, then you can use remedial cementing to kind of repair the corroded casing. This is called what we call a remedial casing. This is usually done once your primary cementing is done. With this, I have my last slide, and let's try to summarize what we have learned so far. Uh, Rig and cementing equipment will depend upon your well requirements and your type of rig. So if you have an offshore oil rig, you have to have a cementing unit mounted on a skid, and that skid will go onto the offshore oil platform. And if you have an onshore rig, your cementing equipment is usually mounted on a truck or on a trailer, um, or it can be skidded as well. But most of the time, it has to be a trailered unit um, with everything on it. Then the cement slurry is pumped through the casing and displaced in the annulus between the casing and the overhead to achieve the zonal isolation. Dry cement and water are mixed at the surface to get the slurry, and they are kept on mixing in the mixing tank until you get the desired density. Once you get the desired density, then it is pumped downhole by a cement unit through a triplex. Uh, uh, it can be a triplex unit. It can be something else as well. For example, a 4x5 as well. That means 4 inlets and 5 outlets. And then it is pumped downhole through a high pressure positive displacement pump at a very high pressure. We have different additives in the cement. So primarily, a cement is made up of Portland cement with additives to get it to the specifications where it can endure the temperature, it can endure the pressure, as well as depths. And then remedial cement jobs are usually performed to solve new or old well problems. These new and old well problems can be a corroded casing, it can be to plug the perforations, it can be for the zonal isolation, or for the plug and abandonment when you are trying to shut down the well. With this, I would like to conclude my presentations, and we can take some questions.
Thank you, Hassan. Yes, as he said, if you have any question, um, you can use a hand reaction to raise a question or leave a comment in the chat. So we have a question from Ismail. Let's see what they have to say.
Yeah, good morning, sir. Yeah,
Good
good
morning.
morning. Yeah, good morning, the host. Good morning, everyone. Yeah, this is my question. What are the environmental considerations and regulations related to cementing operations in the oil and gas industry?
Very good question. Initially, when cementing was new, or I would say exploration of oil and gas is new, I'm talking about early 1900s. There were no environmental regulations, so people could get away with whatever they can. But with the different disasters that we have learned from, for example, the one which I showed you in Algeria, we have Deepwater Horizon in Gulf of Mexico. Probably you guys have seen the movie as well, in which a very bad cementing job resulted in a blowout and a huge environmental catastrophe. And that was because a cementing job had gone wrong. The operator at that point, British Petroleum, was not willing to invest in a good cement job and let it set properly. And they also didn't run something which we called a cement bond log. A bond log is essentially a process in which you try to determine how good your cement is. They didn't run that, and what happened was that there was a blowout which resulted in a loss of a lot of lives, the offshore oil rig, and a huge oil spill that went all the way to the Gulf of Mexico. Um, so a lot of environmental regulations were enacted after that to make sure uh, that the operating companies, the exploratory companies, are following their environmental responsibilities when they are doing the exploration and the drilling phases. API 10A is a very good industry specification that is used as a Bible when we are doing the cementing operations. It will tell you the specifications of the cement, it will tell you the setting time of the cement, and it will tell you what you need to do to ensure that you have done a good cementing job. Not only that, a lot of municipal governments, local governments, as well as federal governments have enacted laws that make sure uh, that not only you do your cementing job properly, so you follow certain steps, but once it is done, you also do what we call cement bond log to ensure that your cement is set properly and there are no voids in the annulus, which can result in a communication between different formations. So there are dozens of laws that have been enacted after the disasters, uh, and all of it is done to make sure that uh, regulatory compliance is maintained.
Mm. Thank you, sir. God bless you, sir.
Thank you.
Oh, thank you.
We have a question in the chat from Asfahab. Um, and he's asking, how can be detected easily at the topsoil part without digging up the fertile soil? Does any signal given machine or by eye looking manual detection, sorry.
Perfect. All right. Very good question. Let me just go to. So, in one of my slides, I discussed life cycle of a well. Usually, the first and foremost is even before the seismic survey is done, the geologist will do a field visit to the locations which are prospective for oil and gas, and they will study the rocks. They will study the different type of formations that they can see on the surface, and they will try to determine what is downhole. But once they have come up to a kind of a idea that there might be oil and gas present, we do something which is called a seismic survey. In the seismic survey, there is a specialized equipment that is deployed, which will shoot these high frequency sound waves into the earth surface. And these high frequency sound waves will travel the earth's surface and they will bounce back. That bouncing back will depend upon the density of the soil, density of the formation. Some formations which are tightly packed, which are very dense, not very porous, will have a better return. Some of them which are highly porous will have a poor return. So you will be able to plot at different depths what your formations are. So you can determine where your topsoil is, where it ends, where your shale starts, where your aquifers are, your water and different type of stones like your sandstone, limestone, and you will be able to determine and you will be able to very accurately plot the formations and depths.
He has another question, and he asks, can we use sand or gypsum instead of cement slurry? And what is the best productive well bore depth?
Sand is used not in cementing, it is used for certain other operations, like, for example, hydraulic fracking. Sand, you need to have certain characteristics of this cement, right? You need to have a certain yield strength of this cement. Sand does not provide you that yield strength. It needs to have a certain setting time, needs to have a certain temperature resistance. Cement, which is a Portland cement, will actually afford you with all these properties. Gypsum or sand, on the other hand, will not afford you all these properties. And also remember, this cement has to bond together to ensure that it does not disintegrate when it goes downhole. And it has to be pumpable as well. That is very important. It has to be pumpable. You can make something very nice and very strong on the surface, but if it is not pumpable, and imagine it has to pump all the way like 2,000, 3,000 meters. So it has to be pumpable.
Okay, okay. We have two more questions from Emmanuel Owure. Let's see what they had to say. Emmanuel, can you unmute yourself?
Yeah, I think, Emmanuel, you are still muted.
Okay, yeah, so sorry, trying to unmute, so it's not allowing me. All right, so my question is, in the drain pipe, yeah, so are there sections where cementing are designed to
Sorry, Emmanuel, you are breaking up.
Okay, sorry, I'm using mouthpiece. Can you hear me now clearly?
I can hear you now, yes.
All right, okay. So I'm saying that in the drain pipe, in the well drain pipe, are there sections where we expect that at this point, cementing should take place, and it is designed for that purpose, or it can happen in any section of the pipe?
So it can happen at any section of the pipe, but usually in the drill plan or the drilling plan, which the engineers will come, they will have cementing operations at certain intervals.
Okay.
Okay. Let's see what Herbert Asuquo has to say.
Thank you so much. I think my question is a little bit digress from a cementing, but related somehow. In the case that the cementing process has failed and there is a spilling, so what is the best method to use in controlling that spilling so that it will not affect the area or extent?
Okay, that's a very good question. Let me show you guys something. So blowout preventer is essentially a safety device that is used to make sure that you prevent your spilling or you will prevent the blowout. This blowout preventer has multiple different subsystems. There is a shear ram, there is a blind ram, and then there is a pipe ram, and then there is an annular preventer. All of these are to make sure that if you have uncontrolled hydrocarbon uh, exposure, then you can actually activate either of these rams to shut down different sections of your casing. For example, if you have a shear ram, the shear ram will just shear the entire pipe and it will seal. So essentially nothing is coming on the surface anymore. So if you have a cementing job gone wrong, and then if you have a blowout or if there is a kick, you close your rams, you shut down your production.
That's good. Thank you.
Thank you. We can answer one question from the chat. And so from Kadaskar, he asked, my question is you see drill oil well and sealed for a long time before is that may creating a problem to environment due to period existence of cement.
Sorry, can you repeat this question again?
Um, he asked, my question is, some see drill oil well and sealed for a long time before. Is that maybe creating a problem to the environment due to period existence of cement?
So cement does not create any environmental problems. It, there is nothing environmentally intrusive about cement as such. Usually when we are doing the plug and abandonment, that means we are shutting down the well for good. Um, the cement usually stays downhole. Uh, it does not contaminate anything. It does not contaminate water. It is usually tested to make sure that it does not have any adverse effect on different formations.
Okay. Let's see what Ismail Adedola has to say.
Yeah, thank you, sir. I have another question, sir. So the question is this: what are some common challenges faced during cementing operations, and how can they be mitigated?
So common challenges that can be faced with the cementing operation is, uh, let's go to this one. So the common is getting the getting your slurry to the right density and making sure that it has certain characteristics. Um, it's a recipe, right? You have to mix certain things at certain time in a certain quantity, so you get that property or that specification downhole. Uh, so usually a lot of lab testing is done on the surface to ensure that your cement has the right properties. Um, Getting it to the right specification is very important. I think that is first and foremost problem that is faced. The other one is the setting time. Um, Usually the oil field drilling is such a high capital intensive, it's such an expensive process that every service is rushing to complete the job. Everybody is rushing to make sure that let's do it because um, it's on the clock, and usually we try to drill more wells in a shorter period of time. Haste makes waste. Um, Giving your cementing job proper time, doing it appropriately with the right pumping conditions, getting your cement to the right specification in terms of mixing, in terms of settling, and in terms of bonding is very important. Once the cementing is done, it's very important to run your cement bond log, which is done through a wire line to ensure that your cement has set up properly and there are no voids in your cementing job. A lot of companies sometimes try to take a shortcut on this one because cement bond log is essentially a service that you can potentially avoid because it's not adding any value. It's not helping you to produce more. It is just helping you to inspect something. So doing that, like to ensure the integrity of your, because there is a concept which is called well barrier integrity. Well barrier integrity means that you need to have two well barriers always in place. Cement is one of that barrier. If it is one of that barrier, it has to be done properly.
Thank you, sir.
We have two more questions from Heber Azuko. Let's see what they have to say.
Thank you. I think based on the picture we are observing now, I'm looking at it means the cementing process need to be carried out before the oil and the oil the basement can be reached, so that it will not start moving up to contaminate the fresh water.
That is so usually that is done once you have reached your desired depth. Once you have reached your desired depth, even if there is oil, it will not go into the borehole because you will have drilling mud over here. So the drilling mud is there to ensure that there is no uncontrolled ingression or um, incursion of oil and gas into the borehole. Drilling mud is
That is the
much more
bentonite.
drilling mud is much more heavier than the oil. It has more density, and it is made deliberately to be heavier so that it can exert that weight on the formation.
Is the drilling mode the bentonite?
No, it's different chemicals. Every company has their own chemicals. Primary, it's clay and water mixed into a slurry, but there are some other proprietary chemicals to it as well.
Thank you, sir.
We can answer the question from Elvis Ondego, and we can answer then the last question that will be from the chat. So let's see what Elvis Ondego has to say.
Thank you, Herbert and Ali Hassan. My question is, in terms of marine life contamination, what is the key component or chemical compound that leads to marine life contamination?
So marine life contamination, usually that will happen on the surface, or when I guess, is your question more related to onshore or on the land, or is it related to the offshore?
Onshore.
Onshore. Okay,
Yeah.
so I will just refer back to this picture. Actually, let's go. Yeah, I think this is better. So you have your freshwater formations right over here. These freshwater formations can get in contact with the surface aquifers like your lakes, rivers as well. Um, I I think it's one. I will probably just reiterate what I said earlier, is that your cement is to ensure that it actually acts like a sealant that you use. It is sealing your salt water from going, or the oil bearing formation from going into your fresh water, because your oil well, if you don't cement it, can result in a communication, and which you can see right over here, right? The cement was not done properly. There were cavities or voids over here, which resulted in the salt water going from its oil bearing formation through the shale into the freshwater formation. So if you do your cement properly, you are essentially making sure that does not happen. When that does not happen, you actually protect your marine life as well as your environment.
So essentially, the level of oil and the level of cement are always on the same rock in terms of the geological formation.
The cement will run throughout all the geological formations.
Okay.
Yeah.
Thank you.
Most welcome.
Thank you. Then we can answer one last question from the chat. From Suru Oyalede. What are the difference between offshore and onshore drilling with regards to cementing and casing?
Good question. I will try to keep my answer as simple as possible. There are two big differences. The first and foremost is, in offshore operations, the drilling, the casings are much bigger. Just because offshore operations, the pressures are very high, the temperatures are high. That is one thing. You have bigger casings compared to an onshore operation. Second thing is that Usually on the offshore rigs, the platform space is very limited. It's super cramped. If you see it, you will see everything cramped into a very small space. Since the space is very constrained, you have very compact cementing units. And these cementing units are usually mounted on a skid. And that skid is installed in the offshore platform. So these are the two big differences.